For most people, an old car reaches the end of its life quietly. It is parked for the last time, left to rust, forgotten. But in the industrial world, nothing truly ends. Here, old cars do not disappear. They are dismantled, crushed, melted, and reborn, not as vehicles, but as the steel structures that move global trade. This is the hidden journey of millions of old cars, from destruction to steel to shipping containers stacked across the world's ports. The process begins with force. Hydraulic breakers strike through
The hydraulic
windshields.
press exerts tons of
Steel
pressure,
claws
reducing
rip
the vehicle
roofs
to scrap
away in a
in
single
seconds.
pull. Car bodies are lifted, dropped, crushed, and torn apart without hesitation. There is no sentiment here, only physics, pressure, and controlled violence. These machines do not destroy for spectacle. They destroy to reduce complexity, to turn a car, thousands of components, into raw material again. Once the initial destruction is complete, the vehicles enter a controlled industrial flow. Remaining fluids are drained, batteries are removed, hazardous materials are separated. What remains is metal. Steel frames, doors, panels, and structural parts are compacted into dense blocks, then fed into shredders powerful enough to tear automotive steel apart in seconds. Inside the shredding chamber, rotating drums grab and rip the metal aggressively. Sparks burst outward. The sound is violent but precise. The output is no longer a car. It is fragmented steel. From here, separation begins. Magnetic systems pull ferrous metals from the mixed stream. Non-ferrous materials fall away, diverted into different recycling paths. Only steel continues forward. This steel is not waste, it is feedstock. Collected, measured, and prepared, it moves into the furnace hall, where
Once the
destruction
graphite
gives way
electrodes touch
to
the scrap, the
transformation.
electrical current surges, melting the metal at temperatures
Inside
up to 3,000
electric arc
degrees Fahrenheit.
furnaces, steel scrap is melting at temperatures exceeding 1,600 degrees Celsius. Solid metal becomes liquid. Chemistry is controlled. Impurities are removed. This molten steel no longer remembers the shape it once had. It is cast into slabs, rolled under immense pressure, flattened into coils and sheets. At this stage, the steel is clean, uniform, and strong, ready for its next life. Not as a car, but as something built to carry the weight of global commerce. The steel coils arrive at the container factory. Overhead cranes lift them onto uncoilers. Steel strips feed into leveling machines that remove any residual stress. Flatness matters here. Precision matters. Computer-controlled cutters slice the steel into exact dimensions. Sidewalls, roofs, floors. Each panel is identical, interchangeable, standardized. Then comes corrugation. Massive rollers press wave patterns into the steel sheets, adding rigidity without adding weight. This geometry is not decorative, it is structural. Corrugated walls are stronger, they resist bending, they distribute load. Next, the frame is built. Corner posts, cross members, bottom rails. Robotic welding arms fuse steel components together with controlled precision. Every weld is repeatable, every joint identical. This frame is the skeleton of the container. Onto it, the corrugated walls are mounted, welded into place. Roof panels are lowered and sealed. At this moment, the container becomes recognizable. An empty steel box, but far from complete. Inside, floor beams are welded. Heavy-duty flooring panels are installed to handle forklifts, cargo, and concentrated loads. Doors are added last. Not simple doors, but reinforced steel systems with locking bars designed to hold under pressure. Every moving part is tested, opened, closed, locked. But building a container is not enough. it must prove itself. Each finished container enters a structural testing hall. Hydraulic systems apply vertical compression directly on the corner castings, simulating the weight of multiple containers stacked above it. The steel does not bend, it does not crack. Racking tests twist the container diagonally, forcing stress into the frame. Floor load tests simulate extreme cargo weight. Door tests push against sealed entrances. Instruments measure deflection down to millimeters. Only containers that pass every test receive certification. These standards exist for a reason, because once containers leave the factory, they will face forces far greater than anything inside these walls. With certification complete, the containers move into real-world handling
This facility
environments.
processes thousands of tons
Reach
of corrugated steel
stackers
every
lift
week,
them.
meticulously
Gantry
organized by
cranes
size and
stack
type
them.
before being shipped
4
out.
high, 6 high, sometimes more. Weight transfers through corner castings. Steel designed specifically to carry vertical loads. This is where the design proves itself. The container does not collapse. It does not deform. It was built for this.
The robotic arms are now active, applying a uniform coat of primer as the containers move through the pressurized booth.
$15.2
Noted. Looks good.
Here we see the pressurized water spray test. The lack of moisture inside confirms the integrity of the seal.
All right, lowering the spreader beam now. Confirm connection at corner posts.
Confirmed, all green. Proceed with the lift.
The immense pressure is distributed evenly across the corner castings, demonstrating the stability of the stack with remarkably low vibration.
So the load test is officially passed.
Yes, everything is within tolerance.
As the weight transfers, the resonance is absorbed, stabilizing the structure at full height.
The steady transit of these containers highlights the massive scale of the coastal port, a critical transition point in the global supply chain.
At Night Falls, this logistics hub operates around the clock, a critical node in the global supply chain, moving thousands of containers every day.